Welcome to the LMS session for program BSc subject mathematics for 6 semester students. This is our 5th session for the topic and the paper transportation problems and assignment problems. In this 5th session, the topic that we are covering is mathematical formulation of transportation problem, and this was created by Dr. Channakeshav Murthy. In the previous session, we understood the concept of this transportation problem, how a transportation problem will be there. Now at the end of this session, we can able to form a mathematical equation for the transportation problem. This, as we have read in the last class, what is this transportation table, how it will be, and what do you mean by a source, what do you mean by a destination, what do you mean by a demand quantity, and what do you mean by a supply quantity, and what are this C11, C12, the cost is cost per unit, this is, and this is the quantity. If you multiply these two, we are going to get the amount for supplying a source from source to the destination, a product from source to destination. What is the cost of a single unit will be here, and what is the quantity, this if you multiply we are going to get, and this row will denotes the supply quantity, this row, and this column will denote the demand row, we can say. Right? Now mathematical formulation, objective function. For solving this, we need a objective function. That is, our aim is to minimize the overall cost of the transportation. So here the objective function is z, and this is the overall cost of transporting a good from source to the destination. Okay, so you can see it here, C11 x11 plus C12 x12 plus so on, it will goes on, we will see it here. So you can see, if you multiply these two things, that is x11 into C11, what we are going to get, this is the amount to supply a product from the source to the destination D1. This is the amount, right? Similarly, if you multiply this to, what we are going to get, this is the amount we have got to supply a product from the source S1 to D2. Similarly for this, similarly if you make all this sum, we are going to get the required amount to supply a product from all these sources to all this destination. Right? So that we have to minimize. Here we are wrote that. Right? So this is the z is the minimization function, we can say. In general, how we can write it, that z is equals to sigma of I is equals to 1 to m and sigma of j is equals to 1 to n, and this is my quantity and this is my unit cost. If you multiply this, we are going to get that amount. So if you make the summation of this, we are going to get the overall the amount. Now constraint, what is this constraints? Constraints are the conditions, they are the conditions for supply and demand, and here there will be two constraints, one is for supply and another is for demand, right? So supply constraint, so we will see the supply constraint. This is my supply constraint, that is this one. How it has been created, here x11 plus x12 plus x13 plus x14, this all should be equal to A1. What is this A1? This is the total supply. This is the total supply I have with the source S1. I will show you in the matrix. Now if you see it here, what is this? A1 is the supply quantity that a source has, that is this godown or this warehouse has a quantity of A1 quantities where it can supply to different destinations, right? This is the overall it has got in stock. This is, I can say, stock at godown S1. This should be equal to all these destinations after supplying. If you supply some quantity to here, some quantity to this point, some quantity to this point, some quantity to this point, then if you add this all the quantities what you have supplied, that should be equal to this A1 that we have wrote. Similarly, this godown has A2 quantities. How much he can supply? Only this A2 quantities he can supply to all the different distributors. He cannot exceed that, right? Therefore this S1, that is X21, X22, X23, X24 is equals to A2. The sum of all the quantities should be equal to A2. Similarly, how much this can supply? S2 source, godown S2 has quantity A3, and how much he can supply? He can supply A3 quantities to all the sub dealers or retailers, that is source to destination. Okay, so this is the supply constraint. You can see it here. This is equals to A1, this is equals to A2, this is equals to A3. These are all are the supply quantities he has with the godowns, or we can say source. In general, I can say that it is nothing but an summation of sigma of j is equals to 1 to n, x of ij is equals to ai. This is the ai is the supply quantity with the godown, and this is the quantity, right? Here it is. So this is the supply constraint, we can say. Now demand constraint, how it has been created? Here you can see this is the demand of a D1, destiny D1. This is the demand of destiny D2. That means sum of the all the products should be equal to the demand. We will see it in the table. Now you can see D1 has demand of B1, including all these sources. If you add all from all the sources, it should be fulfilled with his demand. This source can supply to, this source can supply to, this source can supply to, this source can supply to. So overall demand is then 10. So the demand of the destined D1 has been fulfilled. Like this it is. Okay, that means if you add this quantity, this quantity, this quantity and this quantity, that means it should be equal to B1. Similarly, if you add this quantity plus this quantity, this, it should be equal to B2. Right? That is nothing but my demand constraint. You can see it here. In general, we can write it as summation of sigma of x of ij is equals to bj. Okay, so j is equals to 1, 2, 3 up to n, it will goes. Now next will be the non-negative constraint. What is this non-negative? If x of ij is greater than or equal to 0, be the amount of products to be transported from the origin Si to the destination Dj, then the transportation problem is to determine the x of ij so as to minimize the cost. So here it should be greater than or equal to. It cannot be negative. The supply cannot be negative, right? So here the quantity of supply cannot be negative. Therefore, it should be greater than or equal to 0. That means we can say that for a objective function, the under these conditions subjected to supply and demand and non-negative of the demand, we can say that that is sigma of x of ij, that is the supply should be less than or equal to ai, and the demand should be greater than or equal to b of j, and the non-negative should be always greater than or equal to j. What is this? The first set of constraint equation 1 stipulates that some of the segments from the source cannot exceed its supply, and the second set of constraints equation 2 stimulates that some of the shipment to the destination must satisfy its demand. What is this? So here you can say that the supply of equation 1, that is here equation 1, always it will says that it cannot exceed its demand, it cannot exceed its supply. That is, whatever it is stock is there in the godown, he can supply so much of amount of or quantity of things to each and every distributor or retailer, right? It is, that is the equation. It should be less than or equal to this supply. What I can supply, we can supply from the source to destination, whatever the it is there with us, we can supply that quantity. Okay, and second equation is stipulates that the demand should be fulfilled. Okay, it should satisfy the demand at the same time. If here now, if we have m supply points and n destination points, then how many number of variables will be there is equals to the m into n. If you multiply that type of variable, that much of variables will be there, and number of constraints there, it is going to form is m plus n. Here m plus n, right? So next, so this model describes above that the total supply must be equal to the total demand. When the total supply and total demands are equal, that is sigma of ai and sigma of bj are equal, then it is nothing but an balanced transportation problem. Okay, with the two constraints will be there, supply and demand constraints will be there. Okay friends, so here we will end of this. Thank you.